This is Radhika. I am going to discuss about the power electronics subject. This is for electrical 5th sem students. In last classes we discussed about the so many classes about the power electronics. Now today we are going to discuss about the cycloconverters. Under cycloconverters we are going to discuss the principle and step up and step down cycloconverters. So here in previous classes we discussed about the single phase bridge inverters, and now we are going to discuss about the cycloconverters, definition, types of cycloconverters, classification of cycloconverters and its applications. Now actually what is the cycloconverters? So in this, a cycloconverter is a device which converts input power at one frequency to output power at different frequency. So that is, it will converts the constant input frequency into output frequency. It will be, the cycloconverter is a device which converts input power at one frequency to output power at different frequency. The frequency will be changed. Actually, the types of cycloconverters are two types, step up and step down. So, actually, what is step up and what is step down cycloconverters? The step up cycloconverters in which the output frequency is greater than supply frequency, and in step down in step down cycloconverters the input the in which the output frequency is less than the supply frequency. Actually, we are the classification of cycloconverters are single phase and three phase. In single phase cycloconverter, the transformer with center tapped configuration and bridge configuration. In three phase cycloconverter, the 3 pulse cycloconverters and 6 pulse cycloconverters. So these are the few applications of cycloconverters, that are special control of high power AC drives, and in it will be, the cycloconverters will be used in induction heating and static VAR in VAR generation, and it will be used in electric traction, and also it is used in aircraft and shipboards power supplies. So before going to this one, we can watch the one YouTube video about the basic concept of cycloconverters.
with these outlines. So let us begin this session with basics of cycloconverter. So see, cycloconverter, that is AC to AC converter. And in cycloconverter, we don't use any DC link. So here we convert AC signal into AC signal without using any DC link. So our agenda is to convert frequency. And from name itself, we can understand cyclo means what? Frequency. So cyclo means frequency, and here in cycloconverter we change frequency. So here our agenda is to change one frequency into other frequency without using any DC link. So cycloconverter is AC to AC converter without using any DC link. So it converts AC signal of fixed frequency to AC signal with variable frequency. So there are many applications where we need to change frequency. So by using cycloconverter, we can change frequency without using any DC link. There is one more way where we can change one frequency of AC into other frequency of AC, but where we can convert that AC into DC and DC to other AC frequency, which is very bulky. But here in cycloconverter, we don't use DC link. We directly convert one AC signal to second AC signal. It is also referred as frequency changer, as our agenda is to change frequency. This conversion is done by switches like thyristor and controlling mechanism of it. So in future, I'll explain you many cycloconverter, different types of cycloconverter, where we will be using switches, where as a switch we will be using thyristor, and by controlling thyristor sequence we can convert one frequency into second frequency. So all those things in future I'll explain you step by step. See, if you say this is a cycloconverter, then at input side we will be having AC signal with fixed frequency with fixed voltage, and at output side AC signal with variable frequency and variable voltage output will be there. So ultimately our agenda is to change frequency. So there are two things which we can do. One is by increasing frequency we can use cycloconverter, and second is by decreasing frequency we can use cycloconverter. So all those things that we will see it step by step. So first I'll explain you need of cycloconverter. The cycloconverter can be used to control speed of motor. Here you will be observing there are different types of motor. Some motors are having higher load handling capacity and some motors are having lower load handling capacity. So by changing frequency we can control speed of motor. If motor is functioning with higher load, then there are so many parameters by which we can control speed. One is frequency. So if frequency is been reduced, in that case we can drive heavy load. Like see, if I consider one motor over here, and if I have less frequency with higher voltage, in that case we can drive heavy load, as heavy load cannot be handled at higher frequency. So sometimes we need to reduce frequency, and that we can do it by having cycloconverter. In some applications we need to increase frequency to drive light load. So if you have light load and if you want to handle that fast, in that case we can increase frequency, and that could be done by using cycloconverter. So we can handle light load by increasing frequency and heavy load by decreasing frequency. So this is how we use that in motor. We can use this extensively for some applications where motors are used, like rolling mills, cement, water pump industries. So there are many applications. At last I'll show you so many applications where we need to drive motor with different ratings. So in industries that is very essential to control speed of motor with different rating, and that is where cycloconverter plays important role. So let us see the classifications of cycloconverter. One classification of cycloconverter can be done based on operation frequency. So if we increase frequency with respect to input frequency, then that will be step up cycloconverter, and if we decrease frequency at output with respect to input frequency, then that will be step down cycloconverter. So based on output frequency we can classify that as step up and step down cycloconverter, where in step up cycloconverter we increase frequency at output side, and in step down cycloconverter we decrease frequency at output side. Based on input phase and output phase, again we can classify that in three domain, where there will be one phase input and one phase output cycloconverter. There could be three phase input and one phase output of cycloconverter, or there can be three phase input and three phase output of cycloconverter. So based on input and output phases we can classify that in three domains. So this is how we can classify cycloconverter. Now I'll show you some basics of step up cycloconverter and step down cycloconverter. So let us discuss basics of step up cycloconverter first. So as I have explained earlier, step up cycloconverter is a cycloconverter where we increase output frequency compared to input frequency, and it is not used widely in many applications. Why? The reason is in India and in USA most of the applications are working with frequency less than. Now when we talk about step down cycloconverter, then as per the name we can say frequency at output side will be lower than the frequency at input side.
Now we will discuss about the step up and step down cycloconverter in briefly. But now Now, the principle of operation of cycloconverters. The negative group allows all the negative half waves and also converts positive half waves into negative half waves. The output voltage can be varied by the firing angle of thyristors in both groups. The input and output waveforms as shown in this figure in this diagram. There's the two groups, positive group and negative group, and the signal is AC signal, and in between two groups it has the R load, the voltage is VL load voltage, and in this the figure shows the principal operation of cycloconverter. It mainly consists of two groups of rectifiers, one forming positive group and other forming the negative group, which are feeding a common resistive load R. The input to both the groups is the same. The waveform forms of input voltage Vi, which consist of alternate positive and negative half waves of frequency f. So here in this the frequency are marked as 1 to 8, means here 1 2 3 4 above for half positive half cycle and for negative half cycle. Assume assume at alpha is equal to 0, the positive group allows all positive half waves to pass through and also converts the negative half wave into positive half waves. Firing pulses are given in such a way that half waves 1 and 2, 5 and 6 pass through it and it as figure B. So in second wave, in above first wave one positive, one negative, one positive and negative, but in second waveform it has the two positive, two negative, two positive and two negative. The negative group allows all negative half waves coming to it and also converts positive half waves into negative half waves. The firing pulses are given in such a way that half waves 3, 4, 7 and 8 pass through it. It allows negative half waves 4 and 8 also converts positive half waves 3 and 7 into negative 1 and are shown in this figure. Hence, the frequency of this wave is half and frequency of reference wave. In order to vary the output voltage, the firing alpha must be varies in between 0 to pi. So here this is the waveforms of the principle of cycloconverters, and it has the step down cycloconverter and step up cycloconverters. In SCR, now we can watch the YouTube video of step down cycloconverter.
So current direction, that is in negative direction to the direction of this direction of current. So using cyclo converter. So cyclo converter, that is a circuit which converts AC signal into AC signal without adding any DC element, and it converts frequency F1 into F2. Okay, now here we are using step down cyclo converter. So step down cyclo converter, it means output frequency will be lower than input frequency. So if output frequency is lower than input frequency, then it is step down cyclo converter. If output frequency is lower than input frequency, then it is step down cyclo converter. If output frequency that is lower than input frequency, then it is step down cycloconverter. So basically here in step down cycloconverter, I'll be explaining midpoint type of step down cycloconverter. This circuit is midpoint type of cycloconverter. Why? The reason is here in this transformer we have center tapping, that's why it is midpoint type. And over here cycloconverter means it is AC signal to AC signal converter without adding any DC element inside. So here we will be translating one frequency of input into other frequency of output. This is step down cycloconverter. The reason is output frequency is lower than input frequency. So let us have one example, like how here our aim is input frequency is F and output frequency is F by 4. So here our input frequency is F and output frequency, that is F by 4. And this is what I will be doing it by using this circuit. So now let us try to understand how this circuit functions, and step by step we'll observe what is happening in this circuit. So here we have AC input over here. So what will happen during positive half cycle? So during positive half cycle, this terminal is positive with respect to this terminal, and this terminal is neutral. So this terminal is neutral in all conditions. So during positive half cycle, A is positive with respect to B and N is neutral. So during that time period, this P1 that will come in forward bias and this N2 that will come in forward bias. So at that time, if we trigger P1, then current will flow in this loop like this. So at angle alpha, I'll be triggering P1 during positive half cycle. So at angle alpha, if I trigger P1, current will flow in this loop and we'll be observing output is appearing over here. So that output will be positive. The reason is current direction is this. So if I say at this instant alpha, I trigger P1. So once I trigger P1 at this instant, here one can see this is input, which is what I am plotting. So by this dark yellow line we have input, and this dashed yellow line, it is envelope. Now what is envelope? So ultimately see, one can say this is this dark yellow line, that is AO voltage. So this is VAO voltage, and VBO, that is by dashed line. So this is what dashed line, that is VBO. So when it appears positive, at the time VBO appears negative. So that is how this envelope will be there. Now at angle alpha, will be triggering P1 during positive half cycle. So once P1 is getting triggered, this yellow line output will appear at load. So that is how yellow line output that will be appearing at load. And if this load is inductive load, then slide spike will appear in negative. Slide spike that will appear in negative. Now during negative half cycle, this terminal is negative with respect to this terminal, means B is positive with respect to A. So at that time, this P2 that will come in forward bias, and this N1 that will come in forward bias. But if we trigger P2 during this negative half cycle, current that will flow via P2 like this, and it will appear in this loop. So output will be again positive negative, it means it will be positive. So again at this angle, let us say this is alpha 1 and this is alpha 2. So at this angle alpha 2, if we trigger P2, because of it is passing through this direction, so that is having similar direction as previous direction as it was there with positive upcycle, voltage appear that will be this, and again there will be negative spike due to inductive load, and this is what we keeps on repeating. During positive upcycle we'll be triggering P1 to get positive half like this at angle alpha, and negative spike appears due to inductive load, and during negative half cycle we trigger this P2. So that is how this output waveform appears. So one can say during this interval P1 is on, and during this interval P2 is on. Now I will be triggering other SCR N1 and N2 to get negative half. So what I will be doing is I will trigger N1 and N2 to get negative half. So now during positive half cycle, again at input side A is positive with respect to B. Now at that time this N2 that will come in forward bias and this P1 that will come in forward bias. But if I want negative half at output side, I'll have to trigger N2. So if I trigger N2 at angle alpha 1 as it was there for a positive half triggering, then there will be negative half. The reason is as N2 is getting triggered, current direction that will be in this direction. So now current direction is this. So that will make output is negative. So now that is how output will appear, and due to inductive load negative spike will be there. And if we trigger N1 during negative half cycle, so during negative half cycle terminal A is negative with respect to terminal B. So at that time N1 will come in forward bias, and if we trigger N1, then at angle alpha 2 again there will be a current which is passing in this loop because of N1 is getting triggered. So in this direction current will appear, and in this loop current will flow. So current direction that is in negative direction to the direction of this direction of current. So again one can say here negative half will appear because of N1 is getting triggered. So if I trigger this at alpha 2 over here, now N1 is getting triggered and this negative spike will appear because of inductive load, and that is what we keeps on repeating. And at alpha 2 angle we will be triggering N1. So over here one can clearly see for this period N2 is getting triggered, and for this period N1 is getting triggered. So that is how we will be having negative half. Now if we see the resultant output of this, then that resultant output that is having positive half for this complete 4 half of positive half, negative half at output side, that is there for this complete 4 half of negative half. So we'll be having output that was somewhat like this. So if we see this output, so that is having time period, that is 4t. So frequency that is f by 4. Why? The reason is for one cycle time period is t, but for output one cycle time period is 4t. So frequency of output, that is f by 4. Now here one thing that we need to see, when we trigger this P1 and P2 to get positive half, we will be having rise of current. So if I draw output current, then output current will rise till output is positive, and then once output is 0, it will be decreasing like this. And at this instant alpha 2 is getting triggered, so that is having this kind of output current. So output current will increase till cycle is there, and then one cycle is getting 0, output will current decrease, and that is how output current will appear. So this is what for positive half cycle triggering P1 and P2 will result output current in positive direction, and for negative half output current will be in negative direction like this. So if we see output current over here, then output current is even having
now we watched the step down cycloconverter. So that is that video for step down cycloconverters, and now we can watch the one YouTube video for step up cycloconverter.
Welcome to Power Electronics lecture series. Here in this session I'll be going to explain step up cycloconverter with mid type configuration. So first of all, what is mid type configuration? When we give input to this transformer at output side, this transformer is center tapped transformer. So because of this transformer is center tapped transformer, where from center tapping we take output, this cycloconverter is referred as mid-point type cycloconverter. Now what is cycloconverter? So cycloconverter, that is a circuit which converts AC to AC. Cycloconverter, that is a circuit which converts any DC element. Cycloconverter, that is a circuit which converts AC to AC without adding any DC element. Now here I will be explaining step up cycloconverter. So step up cycloconverter means output frequency of cycloconverter will be higher than input frequency. So if output frequency of cycloconverter is higher than input frequency, then it is step up cycloconverter. So if output frequency is greater than input frequency, then it will be step up cycloconverter. And what is cycloconverter? It is AC to AC conversion without adding any DC element. So if you see this circuit, in this complete circuit I don't connect any DC element. So what I will be doing is I will be changing frequency of output without adding any DC element. That is what cycloconverter, where if frequency of output is higher than input frequency, then that will be step up cycloconverter. So that is what the case which I will be doing over here. And one more thing, in this session my task is to translate output frequency 4 times. So here my output frequency, that is 4 times than my input frequency. So this kind of step up cycloconverter that I'll be going to explain in this session. So let us begin working of this step up cycloconverter with this goal where output frequency is 4 times than input frequency. So here we have this cycloconverter circuit in which I'll be explaining this circuit in case of what will happen during positive half cycle and what will happen during negative half cycle. So this is what my input V in, and
For the step up cycloconverters, we will discuss full explanation in next class. But now, in step down cycloconverters, the SCR based step down cycloconverter does not require forced commutation, whereas step up cycloconverter requires forced commutation. The main drawbacks of SCR cycloconverters are limited frequency of operation and poor power factor at low output voltages. The transistorized switches are performed in step-up cycloconverters. So here, this is about the cycloconverters, basics, simple operation and classifications of cycloconverters. Now, this is the summary for today class. In today's class, we have discussed about a cycloconverter is converts input power at one frequency to output power at different frequency, and the output voltages of a cycloconverter can be varying the firing angle of thyristors. And also we discussed the application of uh, cycloconverters. Here we have the application of cycloconverters, that are we have the few applications of cycloconverters, that are it applicable in low speed high power AC motor drives. It will be used in HVDC transmission systems, and also it is used in static VR generation. It is used in conversion of variable speed alternator voltage into constant frequency voltage in aircrafts and shipboards. Induction heating systems, it will be used in cement mill drives, grinding mills and rolling mills, and also used in mine winders as well as mine hoist, and also used in electric tractions, means in train systems. So here we have the few quiz questions. Cycloconverters are used to step up or step down the mainly frequency. And here also one quiz question. In a dash, the output voltage and frequency can be controlled independent of each other, is the cycloconverter. Next, these are the frequently asked question, that is define and list out the types of cycloconverters. Now, this is the discussion about the cycloconverters. In next class, we are going to discuss about the single phase center tapped cycloconverters. Thank you.